reaction between acetone and methyl-magnesium chloride followed by hydrolysis will give what? Acetone is a ketone H3C, C double bond O, CH3. Methyl-magnesium chloride is the Grignard reagent that we add first. We know that adding Grignard reagent to aldehydes and ketones forms alcohols after the hydrolysis. So, in this case we have a ketone, and we also know that Grignard reagents are strong nucleophiles and strong bases, and this means that this strong nucleophile will attack the electrophilic center here because oxygen is more electronegative than carbon, and therefore the polarity here will be this way: delta negative on the oxygen and delta positive on the carbon. So, this is an electrophilic center, and it's a Grignard reagent is a strong nucleophile. So, that gets attacked on the carbon and your pi bond breaks. The first thing that happens is the pi bond that is there in C double bond O, that breaks. So, you get an intermediate. We basically form a carbon-carbon bond first with the Grignard reagent. That is what we do in the first step, and this MgCl gets added to the oxygen. And then in the next step, that is hydrolysis, what happens is a protonation happens. So, this proton gets added to the oxygen and this OH minus gets added to the MgCl. That is what happens in the next step. So, you get MgOHCl plus an alcohol you get, and that alcohol we need to figure out what kind of an alcohol it is. It is a tertiary alcohol in this case because the carbon atom bearing the OH group, this carbon atom is attached to 3 different carbons, 1, 2, 3, and therefore we call it as a tertiary alcohol or 3-degree alcohol, and that is why option 2 is correct, tertiary butyl alcohol. Why? Because we have 4 carbon atoms in total, and therefore tertiary butyl alcohol is the correct answer here. Instead of acetone, if we had acetaldehyde, what would be the product? In that case you would have got isopropyl alcohol, but here we do not have acetaldehyde, we have acetone, and therefore tertiary butyl alcohol is the correct answer here.